there is an increasing size, that is expansion. Third case, there is a change of state from solid to liquid or from liquid to vapor. Then other one, if you supply heat to the given body, and chemical combustion also a change. And another one, there is a change in electrical properties. If you supply heat to an object, sometimes its electrical property, for example resistance, it will change. Then the last one, there is a change in color also. When we supply heat to an object, the color also will change. Okay. Now this is our real topic starts from thermal expansion. Okay. What is actually expansion? A simple concept is here, expansion. Expansion, whenever we supply heat to the object, there are molecules in that. As we know that there are 3 states of matter, all the states of matter we have molecules in it, and when you supply heat to that object, molecules gain more kinetic energy. Then as a result, if the molecules in the solids, liquids and gases, these particles or molecules, they start to vibrate or they move, these will increase. Vibration or motion of the molecule will increase, and this the material expands. This is our concept. Okay. See, what is actually expansion? Thermal expansion is defined as the increasing volume due to heating. Thermal expansion means a simple concept, increasing volume due to heating. See this picture. The first one is low temperature. There are molecules or atoms in that. So they are very close compared to the second one. When we heat it, the molecules move further apart. That means their vibration increases. The space between them also will increase. Okay. This is our concept. So when you supply heat to an object, molecules gain more energy, they start to vibrate, intermolecular space increases, thus the expansion occurs. So here when the substance expand or contract, okay, same time when we supply heat, it will expand. What about the cooling? Then the molecule come closer, they contract. Okay. So here when the substance expands or contract, the particles stay the same size. That means particle will never expand. Keep in mind, particle will never expand, only the expansion in terms of matter, and the particle stays the same, only the space between the particle increases. When space between the particle increases, that means they start to expand, or volume increases. That is why we mentioned expansion, thermal expansion is defined as the increasing volume due to heating. Next. So as we know, we have studied 3 states of matter already, and we are starting with expansion of solids. So expansion of solids, very simple concept. We know in solids particles are arranged in a very close way. That means particles are closely packed. When you supply heat to it, the same picture as we mentioned before, they are cold situation and hot situation. So heating a solid makes the molecule vibrate more vigorously, and here when you supply heat to the object, molecules start to vibrate or particles start to vibrate more vigorously. So what happens there? As the vibration becomes larger, the molecules are pushed further apart. When they vibrate faster, the molecule move further apart, and the solid expands slightly in all directions. Okay. So molecule will never expand. Molecule will never expand, but the matter will expand. So solid, if you are considering a solid, solid expands. But molecule, keep in mind, molecule will never expand. So this expansion will be all direction. Okay, as we know, expansion is increasing volume due to heating. So here, this expands slightly in all directions. So it could be a length, it could be a width or height. So it's a linear expansion in any way. So reverse happens when solid is cool. Same concept. When you heat object, it starts to expand. When you cool it, they try to contract. So the vibration becomes smaller and the solid contracts, and its molecules are pulled closer together. So temperature decreases or heat energy decreases, molecule cools, and they come closer and force of attraction between them increases. When temperature increases or heat increases, they gain more energy, they vibrate faster, intermolecular space increases, and reverse happens when it cooled. That means the kinetic energy decreases and they come closer, intermolecular space between the molecules increases and they contract. That's what happened. See, the amount of increasing volume depends on type of solid. So different solids shows different expansion. And here a simple example, increasing temperature of 1 meter section of a glass by 100 degrees Celsius will cause it and expand by 9 mm. See, 1 meter glass will expand 9 millimeter when the temperature is 100 degrees Celsius. When we compare with another one, if it's a concrete and steel, they will expand around 11 millimeter when the temperature is 100 degrees Celsius. But when we consider aluminum is here, aluminum will expand almost 25 millimeter. So that's the difference. So this expansion or increasing volume depends on which type of solid we used. This is also a factor. Okay? So expansion in solid, simple concept. Expansion means increasing volume due to heating. When you supply heat to an object, its particles gain more energy, they vibrate faster, the intermolecular space increases and the volume increases. So that's the picture also given same thing. First one cold situation, second one hot. See some examples. As we know, this even though the amount of expansion and contraction in solids seems to be very less. In solids, particles are closely packed or tightly packed. So the expansion will be very less because the particles are very tightly packed, means force of attraction is very strong. Okay? When force of attraction is very strong, heat energy that makes the intermolecular space also will be less. Now here comes to the first situation. Then it can have serious implication in certain situations such as construction industry. And the first case we can see. Example, this is the example, the power lines. How many of you notice these power lines here? See, these power lines, the white colored one is the lines. Okay? Power lines need to be hung from pole at the correct tension or fitness. These power lines are sagged actually. So it's not very tight in between two poles. What is the situation here? If the tension is too tight, what happens? See, there are two seasons we can consider. That's too hot and too cold. That means summer and winter in two situations. Here, first case, if the tension is too tight, the power lines will contract and break in cold weather. As we know, as the temperature increases, molecule come closer, the tension of this wire increases. That means they contract. Tension increases, so the pole will go closer. So that damages the system. The second case, what happened? If the tension is too loose and we are sagged too much, the wire is too loose, then again the problem comes. What is the problem here? They will expand and hang too close the ground, hot weather. That means temperature increases, the expansion will be more and it's very close to the ground, so that also not possible. So it should be a proper tension or tightness, then only we can apply this. The situation is actually expansion. When temperature increases or heat increases, they expand, and in cold weather they contract. See the second example. A thick glass cracks with boiling water because inside expands before outside. This is a very simple concept. You also can experiment it. Take one glass and pour very hot water or boiling water. Okay? There are some glasses, the quality, low quality glasses, they breaks. But there are glasses we use now, I think at home also you are using a good quality one, so it won't break actually. So here thick glass cracks with boiling water because inside expands before outside. Okay? Inside expands before outside. That is when we pour water, actually heat comes from inside. So molecules gain more energy from inside. Okay? Molecules gain more energy from inside, they start to expand. Not molecules, glass starts to expand. Intermolecular space increases, glass starts to expand. So, but the outside expansion will be less. So the entire glass will get cracked. So now heat resistant glasses have very low expansivity. That means if you use a good quality glass, it won't expand that much. So we can pour very hot water also in it. Then other case, expansion in solids, same concept. The first one, a damaged railway track. Second one, the prevention of that. See, railway tracks have been bent and seriously damaged during hot day where the gaps are allowed, expansion was too small. See, before the previous days, we use a railway track, very long railway tracks, they won't give any small gaps in between them. When during summer, the metal start to expand, but the force of expansion is very strong in solids, so they cannot withstand with these concrete pillars. There are concrete blocks there. Actually, the tracks are fitted on concrete blocks. Okay, due to the expansion, these blocks cannot afford that much force. So what happened? The metal, that means the rail, that start expand, so it bent. Okay, that causes a very severe damage to the system. So modern railway tracks laid welded together in length about 1 kilometer. So modern railway tracks, we use 1 kilometer length. So every 1 kilometer we are welding new. So here several precautions are taken to allow for the temperature changes between winter and summer. One precaution is here. Second picture shows that. You can see there is a gap between two blocks. So even if it start expand, so this gap will take that expansion. So it won't make that much stress in this. Okay. So here at the end of the welded length, we can see the end of the welded length of trapped joint is used so that some movement is possible. Even though it expands, there will be some gaps, so it can go easily and come back also. Okay. Summer season it expands slightly, and winter time it can contract also. So a small gap is given, that's a space for expansion. Next one, another example. These all are actually examples. According to our examination point of view, these are the common questions they asked. Okay. For example, the railway track and sagging of power lines and cracking classes, then the bimetallic strip, that experimental concept, everything we are going to basically the examination point of view. The question can come from this. See, first case, there is a bimetallic strip. So what is a bimetallic strip? It's very simple concept. Bimetallic strip means this strip is made up of two metals. Simply we can say two metals. So one is iron, other one is brass. So two sheets of metal, one is at the top and the other bottom, they just stick together. Now the picture shows the first one, iron at the top, brass at the bottom, bimetal strip, the cold situation. When it was cold, nothing happens. Now we are going to heat it. When you heat it, what happens? At the bottom part, from the bottom part, it starts to bend upward. Okay, so it bends upward means there will be some changes in length, some changes in volume. So that shows an expansion. And from this, which expands most? That also another question. Most MCQ paper, even theory also they ask this concept. Okay, which expands most? Here, iron and brass, iron and brass, these are the two cases. Okay, iron or brass, which expands most? In this case, the bottom one, it bends upward. So the the brass expands most. Brass is at the bottom. Okay, brass expands most. Clear the concept? And first again, bimetal strip, there are simply two metals together, and when you heat it, it bends some way. And which will expand most? In this case, the bottom one will expand most because that bends upwards. Okay, then this experiment, if you have these setups at home, you can do the experiment at home also. Just take a stand, a small metallic sphere and a small ring, and initial set, the first picture. There, if you hold it, it can go easily. The metallic ball can easily pass through the ring. Now, secondly, we are going to heat the metallic ball. Okay, the metallic bulb we are going to heat. Okay, the sphere is heated. So as we know, when you supply heat to this system, molecules gain energy, they start vibrate, and intermolecular space increases, expansion occurs. Okay, so and this case is already expanded. Now we are going to put this sphere into the ring. Now it's not going in because it's already expanded. The expansion occurs, so it cannot go in. Okay, This is the third case. So these also simple examples. Question can come here, why the sphere is not passing through the ring. So we can say due to expansion. If they ask to explain in terms of particles, we can say molecule gain more kinetic energy, they vibrate faster, intermolecular space increases, so the volume increases, expansion occurs. Okay? These are expansion of solids. Next one, another example. This is also an examination point of view question. See, why a steel bridge is made to rest on rollers? This is another concept. We can see two pictures, both are actually same in different way just mentioned. When we have rollers at one end, see one end only rollers and other end is fixed. These rollers allowed expand freely without any thermal stress. So here the rollers are given in this metallic bridge that allow freely to expand. That is very important concept. Just imagine there are no rollers in it. There are no rollers. Both sides are fixed firmly. Okay? And just summer season. Here in summer season they try to expand. Which one? The metallic bridge. As we know, metal, they gain energy, they start to expand. When they expand, then the cracks will be there or it's damage. Okay? This is the concept. Now here, when we have rollers at one end, when then there is allowed to expand freely without any thermal stress. In summers, the bridge may expand due to the increase in temperature, and the winter, the bridges may compress due to decrease in the temperature. And the rollers helps to increase or decrease the length of bridge without any thermal stress. So here, so the rollers are actually helping for this expansion, increasing or decreasing length. So in two cases, we can see the simple concept. There is a roller here, and the other case also rollers. So in summer season or winter season, both cases, it expands and contracts. Okay. Next, second state of matter, that is liquids. As we know, liquids, particles are not very close to, and they are little bit free compared to solids, and intermolecular space is more. They slide past each other. They can move also, slightly they can move. So like solids, most of the liquids expands when heated. Like solids, most of the liquid expands when heated. As the temperature rises, the molecules vibrate more further apart and the liquid expands in volume. See this situation. First one, we have some water in the flask, and when you heat it, this blue color rises. Blue color rises, that means the liquid through the capillary tube that expands. So it expands. So we know there is an expansion. When you supply heat to a liquid also, it expands. When you compare the magnitude of expansion in solids and liquid, which will expand most, that is also an important one. We know intermolecular force of attraction is weaker in liquids. So this will expand compared to solid. Liquid will expand most. That's the next point. The magnitude of expansion of liquid is very much greater when compared to solids. Okay? So rate of expansion is more in liquids compared to solid. The reason is in liquids, molecules are loosely packed, and when heated, molecules move further and result in the expands. Simple concept. This expansion of liquid is actually used in a common way, actually used in liquid in glass thermometers. Thermometers, as we know, they are liquids. We know mercuric thermometer and alcoholic thermometer. There are different types of liquid thermometers. So here, in this case, this is in the situation of less heat, and second one is more heat. So here, particles are not very close. In liquids, actually particles are not very close, but when you supply heat, these particles intermolecular space increases, they expand most. This is about a mercuric thermometer. Same thing occurs in alcoholic thermometer. First, the bulb, that means the mercuric bulb, the red dots are alcohol, okay, in second picture. So they are in common 0 degrees Celsius. Alcohol molecules at 0 degrees Celsius. Second one, alcohol molecules at 22 degrees Celsius. Okay, what happens when temperature increases or it gain energy? The intermolecular space increases and the molecule start to rise up. That means the entire alcohol is expanding now. Third one, this is the third state of matter, that is gases. And particles in gases, they are very free to move. Particles are very free to move in gases. So the intermolecular force of attraction is very weak. Intermolecular force of attraction is very weak. They are very far apart. When gases are heated, their particles move with greater speed and energy, resulting in greater space between them, causing the gas to expand. So here, gas start to expand. As we learned before, we know that temperature or heat increases, particles gain energy. The same concept we are repeating every time in solid, liquid, gases. But the intermolecular space and force of attraction will be different. That's a very important thing here. Okay? Every matter, I mean solid, liquid, gases, all the matters will expand, but the rate of expansion will be different. So here in gases, most of the particles or air particles are very loosely packed, they are free to move. So less energy is enough to expand the entire gas. Gas expand much more than solids and liquids when heated. That's another point. So expansion of gas is more than that of solids and liquids. Because the particles in the gas are not held closely together as they are solids and liquid compared to solids and liquid, but they are very free to move in all directions. Okay? And another point here in this picture we can see expansion and contraction of gases. So this is only given in expansion, the case of expansion. So we took a flask and here the air, we fill some air, a lower density liquid we kept there. Okay? Before heating, note the position of the liquid, and after heating, that liquid droplet rises up. When the liquid droplet rises, that means something is pushing from bottom. So what is that here? That's actually expansion of gas. That's a very good concept. Okay, here expansion of gases. So gas expands or air expands and it pushes the liquid up. That means in this case we can identify there is an expansion in gases too. But the expansion depends on the values of pressure, volume and temperature. Gases, the expansion we can't measure easily. Okay, then we can't measure the length, how much it increased by length. But we need to consider three factors, that is pressure, volume and temperature. Three cases we have to consider: pressure, volume and temperature. So we can only measure the expansion in gas by considering the corresponding values of P, V and T. That means P means pressure, V is volume and T is temperature. So just simple concept here. This case we are considering at constant pressure. At constant pressure, temperature increases, volume also increases. Okay? These three cases, I mean solid, liquid, gases, we can consider at constant pressure. Okay? If the pressure is constant, then as temperature increases, volume also increases. Okay? Then if pressure changes, volume constant and temperature also can change. Something should be constant, then only we can measure it. Okay? So three cases: pressure, volume and temperature. Now expansion in gas, as we know expansion in gas is much greater than liquids and solids. So rate of expansion when we compare, gases will expand more than liquids and finally solids. Okay? Then this concept actually related to pressure, but we can explain in expansion also. These cylinders, this is a gas cylinder. As we know, gas cylinder should never be heated. You know why gas cylinders should not be heated? There's a very big concept is inside. See the cylinders at home also we have LPG cylinder, liquefied petroleum gas cylinders are there. Okay, these cylinders we should not heat. It's very strong container. We are using the cylinder as very strong container. Okay, so these containers need to withstand the pressure given from the gas. Okay, here it is extremely dangerous to heat a container containers that store gas, such as gas cylinders or aerosol cans, due to risk of explosion. Okay, and when referring to gases, there are enclosed containers here, and this volume will be same. That means the gas cylinders are fixed. Volume we cannot change. When you heat it, the pressure inside the cylinder will increase. Okay, when pressure increases, what happens? From inside, more force will come to the cylinder walls. If the cylinder cannot withstand that force or pressure given by the gas inside, then the cylinder will explode. Okay, this is the concept. And now this is our summary, and very important 3 cases only in this concept. Thermal expansion is defined as the increase in volume due to heating. Next, when the substance expands or contracts, the particle stays same size. That means, please don't confuse, particle will never expand. Okay, particle will never expand, only the system or the matter will expand. Okay, only the space between the particle changes. And third one, expansion in gases is much greater than in liquids and solids. And when we go to some simple revision question, very fast we can go. Some gas in a sealed plastic bag is cooled. How do the gas molecules behave when this happens? We have 4 options. So here plastic bag is cooled. Keep in mind, they move more quickly and become closer together. They move more quickly and become further apart. They move more slowly and become closer together. They move more slowly and become further apart. From these 4 options, the plastic bag is cooled. Cooled means the answer is C. They move close and slowly and close. I mean, they move more slowly and close together. Second one, a circular metal disc is heated. Which quantity decreases? Now we are going to heat the circular disc. So heat means there will be some expansion. So which quantity decreases? That's our question. Which quantity decreases? Options is density, diameter, thickness, and its volume. Volume, as temperature increases, definitely expand, volume increases. It could be a thickness also, or it could be a diameter also. So the answer is density. So density is the factor when the quantity decreases. Next, the diagram shows a metal foot bridge located in the Sahara Desert, where the temperature is much less at night than during the day. Ends of the bridge are firmly fixed to the sides of a narrow valley. The solid line shows the bridge during the coldest part of the night. This is the solid part. Okay, the solid line shows. Which dotted line shows the bridge at the hottest part of the day? These are the questions they asked in IGCSE papers. Okay, so there is a solid line we can see, that's coldest part of the night. Now we need to check which dotted line shows the bridge at the hottest part of the day. So temperature increases, they expand. So our answer is A. They expand and they move more, take more space. Next one, a liquid at room temperature fills a flask and a glass tube to level X. The flask is now placed in ice and the liquid level in the tube falls to level Y. Why does the level fall? Again, the flask is now placed in ice and liquid level in the tube falls to level Y. Why does the level falls? We have options here. The flask contracts, the flask expands, the liquid contracts and liquid expands. The concept is here the glass tube is level X. Okay, and now the liquid level in the tube falls to level Y. The level is going down. That means the answer is C, the liquid contracts, so the level goes down. When liquid contracts, the level goes down. And next, number 5, the temperature of a bridge rises from 5 degrees Celsius on a cold night to 25 degrees Celsius at midday. What happens to the bridge? Again, temperature from 5 degrees Celsius to 25 degrees Celsius. That means temperature increases. So options are here. It becomes heavier, it becomes more dense, its length increases, and its mass increases. So our answer is C, its length increases. Temperature changes from 5 degree to 25 degree, they start to expand. Okay, intermolecular space increases, the expansion, that is in terms of length here. Now next one, a glass bottle here, and it can be removed easily. After dipping the ball, it can remove very easily. So what happens to allow the cap to be removed more easily from the bottle? So here cap contract, cap expands, the glass bottle contract, or glass bottle expands. Our answer could be here B, the cap expands, so it can undo it very easily. The diagram shows electricity cables being put up on a warm day. The cables are left loose between the poles as shown in the diagram. Why the cables left loose? We have 4 options. They will contract on cold days, they will contract on very warm days, they will expand on cold days, and they will expand on very warm days. Our answer is A, they will contract, because temperature decreases, they contract each other. So this is our lesson, and now you can go through the your past paper or textbook, and all the questions are there. Revise and discuss with your teachers, and okay, then see you next time with new topic.